Hello everyone, Inventor719 here, and in today's video we are doing a fun little experiment to see if we can 3D print a key. I would like to quickly say that this video was a suggestion from one of my subscribers who commented on one of my recent videos. So as always, if you guys have a suggestion for a future video, please shoot it in the comments down below, as I do read all the comments and will try and reply if I like it. So anyway, let's get to the video. So here's some two locks I had laying around. We're going to start with this strongman lock. So as you can see, the metal key obviously works very nicely. So to make this key into a 3D replication, there's a few steps that we're going to do. So step one here was to get the side profile of the key to get the main teeth design into my computer. So to do that, I just used my phone to take a picture of it, and I then emailed it to myself. And as you can see, what I have here on the left is the picture. I just took it on my hand because it didn't really matter. And then I imported the picture into Word to remove the background, as they have a pretty good background removing tool with good tolerances. So as you can see right there, there are all the teeth. And I double checked and it's pretty darn accurate. So now we're going to go ahead and import this into SolidWorks. Okay, so here we are in SolidWorks. Now I'm going to go ahead and create a sketch on the top plane, and then there's a pretty cool tool under Sketch Tools, Sketch Picture. So this is where I can go ahead and import a picture, and I'm going to of course import the picture that we just made in Word. As you can see, there it is right there. Let me get it so you can see a little better. It's hard to focus on a computer screen obviously. So there's the picture right there. Now I'm going to go ahead and use some tools. There's the color tool, is probably the easiest one for this. So you do the eyedropper, select the black background, and begin trace. So it goes ahead and cuts it out, but as you can see, makes it a little bit rough around the edges. So I'm going to go ahead and fix it up, and then I'll show you the end result. So if you do decide to do this, all I did was go down here to color tolerance. I know you can't read that, but that's what it says. And I'm going to go ahead and turn the sensitivity way down, and you can see it rounds out all the corners quite nicely. So now at the very bottom, hit apply, and it's going to turn that outline into an actual drawing. And if I zoom in once it loads, it takes a few seconds to load, but I'm going to go ahead and modify all the exact little points to make sure it's the exact same as the key. So here we have the basic outline of the key, but the issue is that it is not to scale. So to scale this thing, what we're going to do is take the key, and I measured an arbitrary point such as that flat, and I got it to be just about 0.6 inches, almost on the nose. And then using the SolidWorks evaluation tool, I measured this flat on the screen as 16.7139 inches. And by doing some quick math, what I found is that I need to scale it by 0.035899 times. So SolidWorks luckily has a scale feature. I really wish I could show you guys without this big glare here. But there it is essentially right there. So entities to scale, what I'm going to do is go ahead and select every single curvature on the key, just like that. And then I'm going to go ahead and select a scale about corner, and then the scale value, and we're going to hit copy. And as you can see, there's the actual key that I just made way down here, and that is what we're going to be using for our extrusion. Next, what I've done is taken my calipers and measured the thickness of the key as 0.061 inches. And when typing that into the extrude, as you can see, I just extruded the sketch to make the very first outline of our key in SolidWorks. Now the last thing I'll do off screen is add the cutout at the side. As you can see, it gets thicker right at the top, and then we're ready to 3D print. There we have it, everybody, the final key design with a hole for the final touch. As you can see, I added in the curvature as the real key has, as well as all the teeth and the little slot. So I've done my best measuring up everything, and it seems to be pretty accurate. So I saved it as a .stl file, which my 3D printer can read. I import it into the 3D printer right here in the little program, very simple program. And we're going to go ahead and hit print, and let's get it going. So there's the key all 3D printed right there. That was actually the third iteration. The first two didn't work out so hot. So I decided to do the bed, which makes it much nicer for the stuff on top. So let's go take it off and clean her up. So I'm just going to use an X-Acto knife to scrape the key and the backing off. So now as you can see, we have this key on the backing still. It's kind of hard to show, but now I'm just going to very carefully scrape it off of the backing and make it all good. So there we have it, everyone, the final product. There's the key separated from the raft, so obviously I don't need this anymore. And so essentially a quick side-by-side comparison. There's the original, obviously, and here is mine. They are not identical. As you can see, the cutouts are close. Not 100% the same, but very, very close. Now, all that's left to do, I guess, is test it. So, the time we've all been waiting for, it is now time to test. And just obviously, the metal key slides right in, and with a little bit of pressure, but not too much, it opens it very easily, obviously, as it was designed to do so. Now, my initial prediction is that this is not going to work, unfortunately, because the thickness being 0.06 of an inch is quite thin. Now for this PLA plastic, as you can see just from me holding onto the tip and twisting it, it twists very easily. So unfortunately, I think I'm going to end up here with a lock that will never be used again because the key will be stuck in it. Now if the key did turn, there's an okay chance it will work, as the teeth are very similar. I'm not sure on the tolerances on this type of lock, but without further ado, here we go with the testing. First, let's see if the key even slides in. I'm hearing ticking. It's probably my key breaking. But yep, the key is fully inserted, seated on the brass. And the moment we've all been waiting for, I'm going to try my best to get it to not break. Nope, there's no way. I'm twisting it. It does go in and out, but I cannot get it to twist. I wish I could put something on that brass and help it out. Maybe I will. So I've got this flathead screwdriver to try and help it out as best as it can by doing the rotating portion. Nope, I do not think we're going to have success here. I'll keep going just in case, and if it breaks, it breaks. Here we go. Alright, it's not breaking, but it's twisted more than I can explain. So I'm going to try and take it out before I break anything. So, might have been successful in pressing down the teeth, but it is too flimsy to work. So if you do need a secondary key, I recommend just using one of those 5-minute key makers, 1 minute, whatever, in Walmart. So I hope you guys still enjoyed the design process of this video. So please give it a thumbs up if you want to see more 3D printed stuff. And let me know in the comments down below what you want to see. As always, please like, comment, and subscribe. Thanks for watching.